usually the volume integral is introduced, and then questions like this, finding the mass, is done. I decided that this type of a question is a good motivation for understanding why we would need a volume integral. So the calculation will become quite messy later, so forgive me if I have to skip some of the computation later. The important part is to understand what we are doing. Okay. Probably this is the first time you heard the word octant. Guess what that means? Yeah.
Is that like it's like quadrant? So the first.
Yeah, it's like
X, Y.
Yeah. So in the plane, there's 1, 2, 3, 4 quadrants, right? So you have in the 3D space, you have like 8 chambers, right? So you have first one, and then now the question is, it's easy to see what the first octant should be. It should be the place where X, Y, Z are all positive, right? What would be the second octant? And the answer is we don't know. There is no agreement on what the second or third or fourth or eighth octant is. Maybe some people might say eighth octant is where all the X, Y, Z's are negative, but even that I'm not so sure. Okay, so there's no agreement on what the second or any other octant is. The only thing that we agree on is the first octant. First octant is where X, Y, Z are all positive. Okay. So let's try to understand what's happening here. If you first take this and say you take the XY trace. XY trace means you set Z equals to 0, right? So you have 2x plus y equals to 0, equals to 4. If you plug in 0 for x, you get y as 4. So this graph passes through 4 in the y. And if you plug in 0 for y, you get x equals to 2. So 2 for x. And because it's a straight line, this is what you get. And then on top of that, if you set x and y both to be 0, and if you find out the z-intercept, that's plugging in 0 into x and y, so you get z equals to 4. So z-intercept is when you plug in 0 into x and y. And that ends up giving you z equals to 4. How do you visualize that? Well, in the first octant, if you use x, y, and z, we know that the x-intercept is 2, y-intercept is 4. So here's 2, here's 4, here's also 4. Maybe it's a bit higher. Let's say this is 4. It's a bit closer. That's 2. And we know that this is an equation of a plane, right? So because we have 3 points of a plane, there can only be one unique plane passing through 3 points. So it's a plane that cuts through 3 points. And if you use this xy plane, yz plane, and xz plane as the walls that block the first octant, then you get this thing, which is known as tetrahedron. Right? So you get a tetrahedron like, it's not a regular tetrahedron. Regular tetrahedron means like all the shapes are exactly the same, but it's not. But it does have 4 sides, so it's called tetrahedron. And then this object also has a density function, which is like this. What this means is that when x, y, z values are all 0, near the origin, there's almost nothing there. Okay, so it's some kind of material that doesn't have the uniform density. What happens is that as you go further away from the origin, the material becomes denser and denser. And given that fact, now the question is, can you find the mass of this object? That's what this question is about. Does it make sense? Okay. So how do we calculate the mass? Well, we always start out by the principle that the whole is the sum of its parts. You see this type of integral a lot in your physics textbook, okay? And when you see this for the first time, you're a bit suspicious, like, okay, I see what it means, but does this achieve anything? And it actually does. That's the magic of calculus. Now, in your textbooks, physics textbooks, often you're only going to see one integral, because in physics, they don't really distinguish between double integral or a single integral or triple integral like this one. In math, we are more worried about the calculation of things, so we tend to write down triple integral if it's a volumetric kind of integral. And indeed, by this dm, we are really thinking of these small parcels of mass that's making up this whole thing. So we're dividing this entire thing into very small, tiny little things. And because density is mass divided by volume, that's what density is, right? In this context, instead of that, I mean, this is the formula that you use if the density is uniform. Okay, so this is when you have uniform density. But in our case, density is more like you take a small parcel of mass, and we take that small parcel of mass, we look at its volume, and you divide these two. That's what density is, okay? Which means that dm can be written as dv, written as dv times rho. So we can rewrite dm as rho times dv. And then, because we're thinking of these small parcels as a very small box whose increment is in x direction and then y direction. Let me see. And then the length is dz, the height is dz. So think of this to have like a small x increment, small y increment, and small z increment. We're going to think of dv as dz times dy times dx. Now, of course, dv is also same as dx dy dz or dy dx dz. You can write this in any order, but just like in the double integrals, changing that order means the boundary needs to be changed as well. So we will go with dz dy dx because this allows us to take care of dz first, reducing the integral to a double integral over x and y, so it's easier for what we're used to, okay? But of course, even here, you can change the order of integration. Okay, so let's continue calculating this. So we need to rewrite this because rho is 2x plus 6y plus 6z. And then we have to integrate dz, dy, dx. Now the question is, what goes here? We need to fill that in. Okay, now let's see if you understood the double integral well. If I have dz inside, that means I'm painting this three-dimensional thing in which direction?
Z direction.
Z direction, which means I'm going up, right? So we were doing two-dimensional, so we were painting walls, but now we're trying to fill this space. The R is a spatial thing, right? So we're trying to fill that in, moving up, okay? And therefore, I have to provide the information of where does the integral begin and where does it end? Yeah.
You do the 0.
Yeah, it starts at 0 and then
It ends at that line, which is
this not line, this plane.
yeah.
It's
It's
that plane. Yeah, so the top cover is actually this plane. It starts here and goes here, right?
It ends at the XZ trace of the plane already.
No, you really see.
You just make it end up.
Okay. So here's a way to think of it. Because you have dz, anything you write should be thought as z equals to something,
Oh, okay.
right? So you're right that it begins from the bottom, which is z equal to 0, and it ends at this plane, but you have to express it as z equals to something. What is it?
Okay. So Z would equal negative 2x minus y plus 4.
Yeah, that's right. Negative 2x minus y plus 4. Okay. Okay, and then once you integrate out the z, what happens is that if the z directions are all integrated out, the values that you integrate is accumulated, it's like flattened out to the xy plane at the bottom, okay? So if you integrate all the values in the z direction, they all accumulate in the bottom, and what is that? That gets accumulated in the xy trace, right? So the most inner integral gives you the triple integral, but once that's integrated, these two are just double integrals. So can you tell me what goes in for this second one, dy?
Y equals 0.
2?
Negative 2x plus 4.
Yes, because you see, this is the xy trace, right? So you subtract 2x, so it's negative 2x plus 4. Okay, and then what?
0.
0 to what?
X equals.
The last one is, see, this is surface to surface, curve to curve, and then this is point to point, right? Now, once you integrate out the y's, that now you just have something populated down here, okay? So you need to provide two values of x. What are those two values?
0 and 2.
0 and 2. Okay, so that's how you do it. Now, a lot of these integrals are just too much. Like this one is just too much. And maybe I'll just stop here. See, you're going to see some of the questions, even in the practice exam problems, you're going to see something that says, set up the integral but do not evaluate, which means you just set up this much and don't evaluate. Okay. Just to give you a little taste of what goes on after this, it's just same idea. You just integrate everything by z, which means you get 2xz, 6yz, plus 3z squared, and then you plug in negative 2x minus y plus 4, and then you get 0 plugged in here. And then you get dy dz dx, and you have integral from 0 to, let's write 4 minus 2x, and then 0 to 2. So when this is plugged in, you get something very disgusting. Okay, 2x times negative 2 is negative 4x, negative 2xy plus 8x. And then when this is plugged in over here, you get negative 12xy minus 6y squared plus 24y. So this much is when this gets plugged in here.
They were fighting.
And then plus 3, and then you have to square all these. So that becomes 4x squared plus y squared plus 16, but there are cross terms. So you can think of all the pairs and they get doubled. So it's going to be plus 4xy minus negative 2 times 4 is negative 8, but you double that, so negative 16x. And then negative 4y becomes negative 8y. And this much is now integrated from 0 to 4 minus 2x and 0 to 2.
It's negative 4x squared to start.
No, negative 2x, if you square it, becomes positive, right?
But 2x.
Oh, here, I see. Let's see. Oh, thank you. Very interesting. Okay, good. So you get, let's see, 12x squared, so that's 8. Is there any other x squared? No, there isn't. So you get 8x squared. And then negative 2xy, negative 14xy. There's another 12xy that cancels with this one, so you just get negative 2xy. You get 8x, and there's negative 48x, so this is negative 40x. Okay, and then I already did the xy. Y squared, it's negative 6 and plus 3, so it's minus 3y squared. And then 24y, there's another minus 24y, so they cancel away. And then you just have plus 48. Okay, I hope I didn't make any mistake. You see any mistake? Okay. Yeah, well, let's finish it anyways since I started it. I'm regretting a lot. All right, so you now have, what is this? This is 8x squared y minus xy squared minus 40xy minus y cubed plus 48y. You're plugging in 4 minus 2x and 0. 0 to 2 dx. Okay, okay, I give up. So if you're watching this through a video, complete this and reply as an answer.